Section 4.3 is polynomial division. So we'll be doing long division with polynomials. I think at most we just divide by a binomial, so a binomial into a polynomial. And then we'll talk about two theorems that come into play when we're doing this division. One's called the remainder theorem, and one's called the factor theorem. All right, so let's look at what's going on in objective 1. It says, perform long division with polynomials and determine whether one polynomial is a factor of another. So we have one polynomial, x plus 3, and we have another polynomial, x squared plus 11x plus 24, and we want to know if that first one, that binomial x plus 3, is a factor of x squared plus 11x plus 24. Go back to what we know a factor means. A factor means it multiplies to be that number, right? So like before we were doing our factor trees, so we say, okay, what are some factors of 24? What are any two numbers that multiply to be 24? 8 and 3. 2 and 12, 4 and 6, right? So a factor is when you multiply by another factor to equal that number. So how do we know if a binomial is a factor of a trinomial? Basically, if we factor the trinomial and one of the factors is x plus 3, then that means x plus 3 is a factor. So let's just do the AC method real quick with this trinomial. Our A is 1, our C is 24, so our AC is 24. What are factors of positive 24 that add up to positive 11? 8 and 3. So we'll rewrite this as x squared plus 8x plus 3x plus 24. We'll do our factor by grouping. What can we pull out of the first two terms? X. That will leave us with what?
X plus 8.
X plus 8. Perfect. And what can we pull out of the back two terms? A 3, a positive 3, right? And that will leave us with?
X plus 8.
And celebrate the small things in life. They both have a common factor of x plus 8, so we'll pull that to the front. But then what's the remaining binomial? X plus 3. So can we answer this question? Is x plus 3 a factor of x squared plus 11x plus 24? It sure is. There he is, right there. He multiplies by another factor to make that polynomial. So our answer is yes. All right? But then look at the next question. It says, is x plus 3 a factor of x to the 4th minus 5x to the 3rd plus 7x squared minus 5. It just starts getting more difficult, right? So it says this is a more difficult question since the expression is not as easily factorable. This, however, is the question that we want to be able to answer in the section. So we're going to be able to decide yes or no. So let's go back to our basics. Is 3 a factor of 12?
Yes.
Yes, right? 3 times what gets you to 12? 4. So that's thinking factor or multiplication way. But we also can think of division. What we're going to notice here, let's do long division. We're going to put 12 under the division house. Right? I know. 3 as the divisor. And you guys already told me how many times 3 goes into 12. 4 times. So you put the quotient up top, and then 3 times 4 is 12. You put it right below, and you subtract, and you have 0. Okay? What we want to pay attention to is that we have no remainder. And that's what makes 3 a factor of 12, that it divides evenly into 12 with no remainder, okay? So that's actually where the remainder theorem comes into play. If we can divide a polynomial by a polynomial and the remainder is 0, that means that polynomial that we divided by is a factor. So we would say, yes, this is a factor because there's no remainder. What about 3? Is that a factor of 16?
No, because 15 would be 1.
Right, exactly. So she's already kind of doing the math in her head. She's like, no, 3 times 5 gets us to 15, so we have a remainder of 1. So we can just show it. So we can go 5 times, but 3 times 5 is 15, subtract 1. So what do we have? A remainder of 1. So that is no. Okay? And why? Because we have a remainder of 1. So I should probably have boxed all that in. So the remainder theorem here is going to be if A is a factor of B, then B divided by A will yield a remainder of what?
0.
0, right? We do not want a remainder. So if it's a factor, 0 will be the remainder. Thus, when we determine if x plus 3 was a factor of x squared plus 11x plus 24, it technically went in evenly. How many times did it go in? x plus 8 times. I know that looks weird, but that's kind of what we did when we factored. Factor is division. So that went in evenly, there's no remainder, so therefore it was a factor. So what we're going to do is we're going to start doing long division, and it's kind of crazy. So we're going to, again, just kind of remind ourselves how we do it here with just our initial stuff, okay? So let's do 15 divided by 2.
7.
It goes in 7 times, which yields what? 14. So our remainder is 1. Okay? So what we want to keep in mind, this is how they express it, which is kind of weird. We'll write it right up here under our bowl. The polynomial x will be our divisor x times our quotient x plus our remainder x. I know that looks really weird, but what it is, it's all just in terms of polynomials, okay? So our initial polynomial is technically our divisor times our quotient. Your quotient is the answer, okay? Plus your remainder. Does that work for this? Yes. What was our divisor? 2 times our quotient 7. What's 2 times 7? 14. Plus our remainder 1. Does that equal the 15 we started off with? Yes. We don't write it that way with real numbers, but we will with the polynomials back here, okay? So we have x cubed minus 2x squared minus 8 is divided by x plus 2. The first thing I want to point out is, notice in that trinomial, we skipped just the x term, right? Do you guys see how we went cubed, squared, constant? We just skipped x to the first power. Be aware of that, because when we write this polynomial out, we're going to want to put a 0x in its place as a placeholder. Just like 101, we have a 0 in the 10 spot, so we know it's not the number 11, okay? So we're going to have x plus 2 on the outside, and we're going to write x cubed minus 2x squared plus 0x minus 8. Let me get a pen out because I'm going to do something where you guys might not need to do it.
Why do we have to have that 0x?
Because what you want to do is when you divide, you want to divide into every place value, correct? So like if I want to take 1,222 and divide by 2, I want to divide into the 1,000 spots, the 100 spots, the 10 spot, and the 1 spot, right? But there, oh no, you're not going to forget. Just say, is every place value accounted for, right? As a cube squared, oops, I didn't have my x's. I went right to my constants.
So like 3, 2, 1, 0.
Yes, yeah. So it's
Okay,
just
that
it's just
makes
your
more
place
sense.
value. But since it's a polynomial, we don't write 0x. That's just 0.
Why wouldn't
But when
it
it's a
be
number,
1?
we write 0 and that place value.
Why
Okay?
wouldn't it be 1?
Because 1x means there was an x there originally,
Oh, yeah.
right? And so how do we represent it without it being there? 0. Okay? So how we do this, we kind of just think backwards. So how did we do 2 into 15? Well, we asked ourselves, what times 2 got as close to 15 as possible? And we said 7, right? So what we're going to do is we're just going to focus on this leading term, the x, and we just say, what times x gets you to x cubed?
The x
To the third.
X not to the third, because we already have an x.
Times x.
X to the second. Do you guys agree, right? What do we need to multiply x by to become an x to the third?
Oh, if you multiply them, then
You add the exponents, right? So if we already have one exponent and we need to get to 3 as our exponent, we need 2 more x's, right? So we're going to put an x squared up top. Is that okay so far? All right, so then how did we get this 14 down here? We said, okay, we knew as close to 15 we could get was 7, and so then we multiplied 2 times 7, which was 14. We put the product down there, right? So what am I going to do? I'm going to take x squared and multiply him by x and 2 and just put him right down there, okay? What is x times x squared? X to the third. That's why we picked x squared, correct? Okay? What is x squared times 2? Or 2 times x squared? Just 2x squared. Do you guys agree with that? Are there any questions so far? So I'm just mimicking this, right? We said 2 went into 15 7 times, but 2 times 7 was 14, okay? We said x went into x cubed x squared times, but x squared times x plus 2 is x cubed plus 2x squared, right? We just multiplied him by each part. Then what did we do with the 15 and 14? subtracted. So what are we going to do? So this is where it gets hard. So I don't know if you have like an extra pen or a different color, or if you just do it with your pencil, it's fine. What we're going to do is we want to subtract this, but we want to subtract all of it, right? So here, 15 minus 14, it was easy to see that we're subtracting both the 4 and the 1. Here, if we're subtracting x cubed plus 2x squared, what do we have to make sure we do with that negative? Distribute it, right? So it's really a negative x squared and a negative 2x squared, right? I'm distributing to him. So now it makes him negative and him negative. Do you agree with that? And I can kind of get rid of him now because I already distributed him. What should always happen is your first two terms should always cancel out if you did it properly, right? So what's x cubed minus x cubed?
0.
0 or nothing, right? So we won't worry about that. And then what's minus 2 minus 2?
-4.
Negative 4x squared. Perfect. And then bring down the rest of your stuff. Is that okay so far? Then you just start over again. You say, okay, what do I need to multiply my x by to get a -4 and an x squared? Well, what number do we need for sure? How do we change?
A negative.
-4, right? And how are we going to change from x to x squared? Another x. So we just need to multiply by -4x. So you'll just put that right up top. Is that okay? Once you put the answer up there, don't forget to multiply him by both the x and the 2 to put them down here. All right? So what is -4x times x?
-4x squared.
-4x squared, that's why we did it, right? You always want that to match. What is -4x times a positive 2? So what's -4 times 2?
8.
-8, and then the x tags along. So that's just -8x. And this kind of answers Riley's question. If we didn't have the 0x there, we would have just had an 8 and we would not have lined up, right? We'd have an x term, -8x, and then an 8 there, and we couldn't do that math because they're not like terms. So we have to make sure we have all the place value there. All right, what do you do after you multiply? You need to subtract it, but we have to subtract the whole thing, right? So what am I going to have to do with that negative? Distribute it, and it's going to make both of those signs change to positive. So however you need to do that, okay? So he'll go here, and he'll make that positive, and he'll go here, and he'll make that positive, and then we don't have to worry about it on the outside at all. If you do it properly, what should always happen with the first two terms? They'll cancel, right? So -4x squared and plus 4x squared we know is gone. And then what's 0 plus 8?
8.
Just, no, it's positive because we're adding it, right? So it's just 8x. And then bring down the -8. And we're almost done, okay? What do I need to multiply x by to be 8x? Just an 8, right? I have the x, I match the x. So I need to just multiply it by a positive 8. So what is 8 times x? 8x, good. That's why I wanted to do it. What's 8 times 2? 16. But after you multiply, what are you supposed to do? Subtract, right? And you subtract the whole thing. And I already heard Riley saying it. We're going to distribute, okay? So he's going to go here, and he's going to go here. So what happens with the first term, 8x minus 8x, cancels. And then what's a -8 minus 16? Nope, because we're minusing it. We're going to go more negative.
Yeah, so it's going to be
-24, does that sound right? So that's our remainder, -24. All right, how does my math lab want you to write this? I need to write this so we have room. If you have room, hopefully. If not, we can kind of write it off to the side over here. How my math lab's going to want you to write it is kind of in this form. So we have our original polynomial, p of x, and we divided him by x plus 2, so that was our divisor, right? Actually, I don't even know if they want you to do that. Let's just note what we have. I don't know if they want you to put it all together, okay? So let's just note,
It'll like, because I already already did it.
Okay, I think it says what is Q of X, what is R of X, I think is
Yeah.
what it wants.
You
So it
just
just wants,
fill in the blank.
yeah, so it wants the quotient, which that's your like polynomial that you get, that's the answer. And then it wants your remainder, and that's just who we have left over, okay? So this just wants x squared minus 4x plus 8, and this just wants a negative 24. Okay? But what's interesting, and not that we want to do this to check it, but what we can do, guys, is we can follow this form right here. We can take x plus 2 times our quotient of x squared minus 4x plus 8, distribute all that stuff, gather like terms, and then add our remainder of negative 24, and it will be our original trinomial of x. It's weird. Like, there, you can check it if you need to check it. Okay? So guess what? Not the hardest thing,
I don't like it.
but there's a simpler way, okay?
I liked it.
So-
Until it got really complicated.
What'd you say?
I liked it for the first row, and then it got.
Yeah, and then you're like, oh gosh. And it's not that it's even hard, but there's a lot of room for error when you like subtract and you want to make sure you distribute the negative and so forth. But the whole thing is, what do I need to multiply by to get that, right? Like, what did I need to multiply x by to get to x cubed? 2 more x's, so x squared, right? What did I multiply x by to get negative 4x squared? I need the negative 4 for the coefficient, but another x to make the x squared. So that's why it was negative 4x. You kind of just ask yourself that way, okay? So if, we're going to stop there as far as the long division way, and we're going to flip it over to the top of page 2 and do it using synthetic division, which is a shortcut, okay? And what's nice about synthetic division, it's considered a shortcut because you don't have to worry about the variables, you're just concentrating on the coefficients, okay? So, but we're going to still pay attention that every place value is held. For example, looking at here, we have third to blank 8, right? So we're missing that x to the first power again, all right? So the only thing different is, if you want to know if he's a factor, you want to divide by negative 2. So you're always changing the sign there for it to work, okay? And that, by changing the sign there, that's taking into account all those subtractions that we do, okay? So we just change the sign in the very beginning, and then we go with that. All right, so he's who we're dividing by, so he gets to be up on a shelf. Here he is. He's on a shelf here, okay? And behind the shelf, we're going to write all the coefficients of each of the terms and put in a 0 if one term is missing, right? So the first term was to the third power, but what's its coefficient technically?
3.
Nope, 1. The degree is 3, right? Negative 2x squared is the second term. What's its coefficient?
2.
Negative 2. Keep the sign with it. We're missing the x term, so what are we going to put? A 0, exactly. And then what's our constant?
8.
Negative 8, okay? Leave a row for us to do some answering here, okay? This one's pretty interesting. It's kind of neat how it works. Okay, so what we first do is you always bring down the first coefficient. Bring him down. There he is. He's hanging out, okay? Then from here on out, guys, everything's the same way, which is kind of neat because it's consistent. After you bring the first coefficient down, you're going to multiply your divisor, negative 2, by whatever our number is down there. So what's negative 2 times 1? Negative 2. And then you put them in the next place value. And then we just add. What's negative 2 plus negative 2?
Negative 4.
Negative 4.
Hold on, we're going too fast. He said negative.
So you bring down the first coefficient always, 1, and then you multiply your divisor by that number. So negative 2 times 1 is negative 2, and you just bump them up there. Okay? And then you add. Negative 2 plus negative 2 is negative 4. But then you do the same thing. What's negative 2 times negative 4?
Positive 8.
Positive 8, and he goes up there. What's 0 plus 8?
8.
8. What's negative 2 times 8, though?
Negative 6.
Negative 16, and he goes up there. What's negative 8 plus negative 16? There's our remainder of negative 24. Okay? So what we did, you're going to see something really cool happen here, is what we did is we came up with all the coefficients of the next polynomial, the quotient, okay? So notice on the front, when we divided a trinomial to the third degree by a binomial that was to the first degree, it just reduced the power by 1, right? So we have x squared x constant, right? So that's what we did here as well. We took a third degree polynomial and divided by a first degree polynomial. So all it's doing is just making this go down by 1. So this is the x squared's coefficient now, this is the x term's coefficient now, and this is the constant now. And that's our remainder, okay? So our q of x is going to be 1x squared, and you don't even have to put the 1 there, right? Minus 4x plus 8. And what's our remainder, guys?
24.
Yeah, there, he'll always be our remainder. And isn't that what we just got on the other one?
That's a lot easier.
And at first it's kind of awkward, okay? But once you get used to it, it's definitely the easier method. Yes, what were you going to say?
Yeah, that's what I was going to ask. I didn't notice it was the same problem. I was going to ask, can you do that with the first one we just did?
Yes, and it's the exact same problem, so just to prove that you get the exact same thing, okay? So key thing to remember is that you first of all are dividing by the opposite. So what are we going to be dividing by in this one? -3. So put -3 up on the shelf here, okay? And then again, make sure all your terms are represented. And notice we don't. We have the fourth term, third term, and then we skip to the first degree. So we're going to have 2 for the fourth degree, 7 for the third degree, 0 for the second degree, right? 1 for the first degree, and -12 for the constant. Do you guys agree with that? Oh, I'm off the side, sorry. Is that okay? Because again, we want to go 4, 3, 2, 1. We're missing the x squared term. So what do I have to put in his place?
Oh.
A 0. It's that
So it has to
placeholder.
be fourth or-
It just always has to start with the highest degree and go down by 1. So if
Go
you
to a
skip
constant?
over, all the way to a constant. So if you skip over something, you need to put a 0 there. All right, do your horizontal bar, but leave a gap, right? The first term always comes down, that coefficient always comes down, and you have 2, and then you just start from there. What's -3 times 2? -6. What's 7 plus -6?
-1. Like 1.
Positive 1, right? What's -3 times positive 1? -3. What's 0 plus -3? -3. What's -3 times -3?
6 positive.
No, 9?
Oh.
9, it's okay, right?
Yeah.
And then what's 1 plus 9?
10.
10. What's -3 times 10?
-30.
-30. And what's -12 plus -30?
-42.
-42, okay? So we now have our new coefficients, but what degree did we start with? A fourth degree. So what have we gone down to? A third degree. So this is 2x to the third plus x to the second. If you want to put 1x squared, that's fine. Minus 3x plus 10. You see what I'm doing? And then what's our remainder?
-42.
Okay? So what, why is this so crooked?
So do the little number things go down by 1 every time?
Yes, so whenever you take a fourth term and reduce it by 1 term, it's always going down by 1. So now instead of a fourth degree polynomial, we have a third degree polynomial left. And that would be different. And I don't think we do anything like that, but if we took a fourth degree and reduced it by a second degree, it'd go down by 2, because it's just whatever you're dividing by. All right, so that is called the remainder theorem. If you have a remainder of 0, you know it's a factor. So is x plus 2 or x plus 3 a factor of each of those?
No.
No, right? So let's see ones that are or are not, okay? So for the function f of x equals x cubed minus x squared minus 17x minus 15, determine whether each of the following is a factor. So we're going to divide and then remainder, question mark? Okay. Oh gosh, I'm like way down there, sorry. So what we're going to do is, I don't tell you how to divide. So do you want to do one with or without? Do you want to try to do long division again to practice it? Okay. So what are we going to divide by on A?
5.
-5. Remember, it's always the opposite sign that's going to sit on that shelf. And then notice this goes third, second, first degree constant. So every term or place value is held. So we have 1, -1, -17, -15. Does that look okay? Bring the 1 straight down. What's negative 5 times 1? Negative 5, he goes up there. And then add, what's negative 1 plus negative 5? Negative 6. What's negative 5 times negative 6? No, we're multiplying.
Oh.
Negative 5, oh, negative, positive 30.
Positive 30,
Oh my
right?
goodness, I cannot do this.
And then what's negative 17 plus a positive 30? 13. What's negative 5 times 13? Negative 65. What's negative 15 plus negative 65?
Negative 70.
Negative 80, because we'll add 5 and then we still have the 10, right? It's okay. We can use our calculators, right? Okay, so notice it doesn't say what's your quotient, what's your remainder. It just wants to know, is x plus 5 a factor?
Yeah, it's the remainder.
We do have a remainder. We have a remainder of negative 80, right? So no, since we have a remainder, since r of x is something other than 0, right?
So if that last number is 0, that's how you know it's the remainder.
Yes, the remainder is 0. So it's a remainder no matter what. So this is a remainder of negative 80. That was a remainder of negative 24 and negative 42. But as long as the remainder is 0, that means you went in perfectly. So you're a factor. This had a remainder of negative 80, so it's not a factor since our remainder was something other than 0. All right. So on B, guys, what are we going to divide by on B?
Negative 1.
Negative 1. So he's going to go up on the shelf. And what's nice is we've already done the same polynomial. So you can just steal this line over there, right? So 1, negative 17, negative 15. Leave a space. Do your horizontal bar. Bring down the 1. What's negative 1 times 1?
Negative 1.
Negative 1. What's negative 1 plus negative 1?
Negative 2.
Negative 2. What's negative 1 times negative 2?
Positive 2.
Positive 2. What's negative 17 plus 2?
Negative 15.
Negative 15. And look what's going to happen. What's negative 1 times a negative 15?
Positive 15.
Positive 15. And what happens with those two terms?
0.
Goes to a 0. So what's that mean? I know, isn't it nice though? So what does that mean about x plus 1?
It's factor.
It is a factor, right? Yes, a factor. Why? Because our r of x equaled 0, right? And right now, you're like, okay, big whoop, what does it mean? In 4.4, we're going to find out what it means. Because if we can figure out one factor, we can figure out the other one. So we'll be able to figure out all of our zeros. And that's actually what the next little guy is right down here at the bottom. I know he's barely on there. But this is called the, make sure, the factor theorem here, okay? So it says, suppose that you find that x plus 3 is a factor of some function. What else would you know about that function? Well, think what we've been doing lately. Why do we factor? Well, we've been factoring to find our zeros. Remember that worksheet that you just did where you had to factor it and set it equal to 0 and find your zeros? And it was just a matter of changing the sign over, right? So if you have a factor, the value in that factor with the opposite sign is a 0 of the function. And that's all it's saying. I know it looks really wordy, but it just says if x minus c is a factor, then that means c, its opposite sign, right, would be a 0 of f of x. What does that mean? It means on this crazy polynomial right here, we know that we would be crossing the x-axis at -1. Because x plus 1 was a factor, we would have set it equal to 0, moved the 1 over, and had x equals -1. So, on the third page, we're doing the exact same stuff, you're just asked a different way, okay? So look at the top of page 3. It says, determine whether 4 is a 0 of f of x. I think you do. No, you do 4 because notice that it will match, okay? I'm glad you're thinking that way. When we find that it's 4, it technically came from x minus 4, okay? So notice here, sorry, how this was a minus c, but it made positive c It's because, but what would we have divided by here? A positive c, okay? So the numbers will match. You won't have to change the signs. The only time you have to change the sign is if they give you the binomial. Like, is x minus 4 a factor? And then you change it by 4. So we're just going to divide.